Boltzmann Brain falsifies multiverse. How the Boltzmann brain falsifies the multiverse hypothesis. The multiverse hypothesis has become a popular explanation among some cosmologists and theoretical physicists to address various issues in cosmology, such as the fine-tuning of the universe's physical constants. According to the multiverse hypothesis, our universe is just one of countless others, each with its own set of physical laws and constants. While this idea offers a potential explanation for why our universe appears so finely tuned for life, it also raises several profound philosophical and scientific problems. One of the most significant of these problems is the Boltzmann brain paradox, which, when taken seriously, presents a strong challenge to the multiverse hypothesis. In this video, we will explore what the Boltzmann brain problem is, how it arises in the context of the multiverse, and why it potentially falsifies the multiverse hypothesis. Understanding the Boltzmann brain problem. The Boltzmann brain problem is named after the Austrian physicist Ludwig Boltzmann, who made significant contributions to statistical mechanics. Boltzmann proposed that the universe's low-entropy state could be explained by random fluctuations within a larger, high-entropy system. According to this idea, given enough time, a large and complex fluctuation could occur by chance, producing a universe like ours with low entropy. However, this idea leads to a troubling paradox when extended to the multiverse or certain cosmological models. In an infinitely large or old universe, or multiverse, where random fluctuations occur, it would be far more likely for a conscious observer, a Boltzmann brain, to randomly fluctuate into existence out of a high-entropy environment than for an entire universe like ours to arise from a low-entropy state. This is because a single brain, complete with false memories and perceptions, requires far fewer p-videos and less complexity to form than an entire universe. The Boltzmann brain paradox in the multiverse context. The multiverse hypothesis, especially when combined with the concept of eternal inflation, posits that new universes are constantly being created in different regions of space. Each of these universes could have different physical constants, laws, and initial conditions. In this framework, the Boltzmann brain problem becomes particularly acute. In a multiverse with an infinite number of universes or an infinitely old universe, the probability of Boltzmann brains arising through random fluctuations would vastly outweigh the probability of entire, orderly universes like ours forming naturally. If this were the case, we would expect that most observers in the multiverse would be Boltzmann brains rather than beings like us, living in a stable, low-entropy universe with a coherent history. However, this expectation contradicts our experience. We do not observe ourselves as disembodied brains spontaneously arising in a chaotic environment. Instead, we find ourselves in a large, stable universe with a long history that supports complex life. This discrepancy between what the multiverse hypothesis would predict and what we observe is the core of the Boltzmann brain problem. Why the Boltzmann brain problem falsifies the multiverse hypothesis. The Boltzmann brain problem presents a serious challenge to the multiverse hypothesis because it undermines the very basis of empirical science and observation. If the multiverse hypothesis were true, and if the creation of Boltzmann brains were vastly more probable than the formation of entire orderly universes, then we should be Boltzmann brains. Since we are not, this suggests that the multiverse hypothesis, at least in its current form, is flawed. 1. Undermining empirical science. One of the most fundamental principles of science is that our observations of the universe are reliable and reflect an objective reality. The Boltzmann brain problem calls this into question. If the multiverse hypothesis implies that most observers are Boltzmann brains, then it also implies that our observations could be mere illusions created by random fluctuations rather than accurate reflections of a stable, external world. This undermines the reliability of scientific reasoning and empirical observation. If we cannot trust our observations to reflect reality, then the foundation of science itself is compromised. Since the multiverse hypothesis leads to this conclusion, it suggests that the hypothesis is not consistent with the principles of empirical science. 2. Probability and expectation. In any scientific theory, predictions about what we should observe are based on probability and expectation. If a theory predicts that a certain outcome is overwhelmingly likely, but we observe the opposite, this is strong evidence against the theory. The multiverse hypothesis, when combined with the idea of Boltzmann brains, predicts that most observers should be Boltzmann brains. However, we observe that we are not Boltzmann brains, which is a direct contradiction of the theory's predictions. This mismatch between prediction and observation is a powerful reason to question the validity of the multiverse hypothesis. If a theory consistently makes predictions that are at odds with what we observe, it is generally considered falsified or in need of significant revision. 3. The problem of infinite regress. The Boltzmann brain problem also introduces the issue of infinite regress within the multiverse hypothesis. If the multiverse itself requires fine-tuning to avoid the dominance of Boltzmann brains, this fine-tuning must be explained. However, any explanation for this fine-tuning might itself require further fine-tuning, leading to an endless chain of fine-tuning requirements that the multiverse hypothesis cannot satisfactorily resolve. This infinite regress makes the hypothesis less plausible as a fundamental explanation for the universe. Alternative explanations and the search for a better theory. Given the problems posed by the Boltzmann brain paradox, it is clear that the multiverse hypothesis, at least in its current form, is not a complete or satisfactory explanation for the universe we observe. This has led some physicists and philosophers to explore alternative explanations or to refine the multiverse hypothesis in ways that might avoid the Boltzmann brain problem. One alternative is the idea that the initial conditions of our universe are not the result of random fluctuations but are instead determined by some deeper, underlying principle or theory. This could involve a theory that naturally suppresses the formation of Boltzmann brains, ensuring that most observers are like us, living in a stable, low-entropy universe. Another possibility is that the multiverse hypothesis is simply incorrect or incomplete and that we need a different framework altogether to explain the fine-tuning and order of our universe. This could involve new physics, a better understanding of the quantum nature of reality, or a completely different approach to cosmology. Conclusion. The Boltzmann brain problem presents a serious challenge to the multiverse hypothesis, raising questions about its validity as a scientific theory. The fact that we observe ourselves as coherent beings in a stable universe, rather than as disembodied brains arising from random fluctuations, suggests that the multiverse hypothesis, if true, is either incomplete or fundamentally flawed. This problem highlights the need for a more robust explanation for the fine-tuning and order we observe in the universe, one that aligns with our empirical observations and avoids the paradoxes introduced by the multiverse. As the debate over the multiverse and the Boltzmann brain paradox continues, it remains an open question whether a revised multiverse hypothesis can overcome these challenges or whether an entirely new framework will be required to explain the fundamental nature of reality. Thanks for watching. Please like, share and subscribe, and comment below if you agree or would like to add your thoughts.